connected to your home computer. Okay, let's review. What do we have so far? We have the locations of our energy resources. We have the output potentials and distribution qualifiers, which are based on strategic use, technological harnessing, and proximity. And finally, we have a system of active resource monitoring, which reports the state of energy supply, rates of usage, and any other relevant trends. In other words, we've created a systems approach to energy management on the planet. The system is comprised of real-time data and statistics. The process of unfolding is based not on a person or group's opinion, not on the whims of a corporation or government, but on natural law and reason. In other words, once we establish the interest and goal that survival and hence sustainability is our goal as a species, which I hope everybody in this room agrees, then each parameter to consider in regard to resource management becomes completely self-evident. It is called arriving at decisions as opposed to making them, which is a subjective act based on incomplete information and very often cultural biases. The planet is a holistic system with resources all over it. Therefore, the efficiency of human society can only come from an integrated systems approach to the management of those resources and hence social processes. The planet demands it, if you will. The only government that exists is planetary operations, is natural law. It is inherently negligent, illogical, and irresponsible to function in a detached manner. We require a holistic system. Okay, using this energy model as our procedural example, this systems approach can be applied to every other earthly resource and quantifier. We survey, find potential, qualify for negative retroactions, and apply modern technology to harness, distribute, and monitor in the most logically advanced, holistic way possible. Naturally, a computer database management program would be the logical method to navigate these issues, where all the attributes we have discussed are fed in with strategic computation applied. And since the goal is holistic maximum efficiency, the automation of adjustments also becomes very simple. For example, let's say we have two geothermal power plants in the same region, each outputting in tandem the required amount of energy for that region. One day there's a problem, and the output of one plant drops by 30%. This would be seen by the monitoring system, and the other power plant's output would be automatically adjusted by 30%. It is reactive, just like the nervous system in your body, automatic. No reason to vote for it, no reason to debate it in Congress. It's automatic because it's self-evident. So, to summarize this approach, all planetary resources, from energy to minerals to maritime life, etc., are managed by strategically active statistical processes in a single global system which is programmed to adjust automatically to the changing environment. That's it. Correct me if I'm wrong, but I'm afraid there is no other way to achieve peak efficiency of our resource usage. It is a technical process. It's also very, very simple when you think about it, even though the specifics of implementation would seem complex for most of us who are untrained in systems engineering. Okay, so we have a global resource management monitoring system now, utilizing programming and feedback to maintain what we call dynamic equilibrium and peak efficiency. So, how does this same logical systems approach to management apply in regard to seemingly more complex mediums of social operation, such as the production of tangible goods for everyday human consumption? Well, we have a clear picture of our pool of useful resources, so the question then becomes, what do people need? This is actually quite an elusive question. On one side of the spectrum, you have the immutable necessities of life, such as food, clean air, water, and the like, while at the other extreme, we broach issues of vanity, material tools, leisure goods, and other issues which basically vary from region to region, culture to culture, and generation to generation. This latter part regarding value-based needs will be addressed somewhat later. But for now, we're going to focus on the former, the basic necessities of life for all of us. Food and water. Naturally consumable water supplies, or fresh water, would be sourced as part of our initial global survey and regulated and monitored as we've discussed. When it comes to food, the first to consider is agriculture and then hence arable land. So we survey and locate all available arable land on the planet. Then we establish consumption statistics based on the population's usage. Now, obviously, analysis would become much more complex than what I'm denoting here because there are many things to consider, such as the growth propensity for certain crops, the methods used for cultivation, the need to counter negative retroactions, and many other fine points. However, once again, each one of these issues can be isolated, recognized, and quantified to one degree or another systematically. I want to continue to address the process. That's the most important point. Now, to extend this point, the conventions used for cultivation and preservation of food and water right now only takes us so far. This is an area where technology becomes critical in light of our growing population. In society today, food and water scarcity is massive in developing nations. Here is a projection done by the IRRC regarding water scarcity by 2025. In turn, as of now, 1 billion people are starving on this planet, according to the United Nations. It's probably a lot more than that, considering how the United Nations tends to whitewash such issues if you pay attention, but nevertheless, it's still insane. And anyone who's paying attention knows that the problems of food scarcity and water scarcity is 100% economic. The technical resolution of the problem can happen with the mere application of existing methods, namely desalination and hydroponic agriculture. Technological advancements such as desalination processes can make fresh water both from seawater and even brackish water sources, using reverse osmosis along with other developing methods. This is yet another example of how technology is just as much a part of resource management as resources themselves. The idea that usable water is scarce is only true in relationship to the limited methods we are currently using, compounded, of course, by the economic nonsense we have already mentioned. The same goes for hydroponics, which is a method of growing plants using mineral nutrient solutions in water without soil. In fact, we could theoretically grow food in the middle of the Sahara Desert with proper irrigation by simply tapping down to the water table. I believe it's about half a mile to a mile down. It might sound like a long way, but again, many things that seem extreme to us today become commonplace through time. And, by the way, I hate to sound negative, but if the United Nations was truly concerned about the well-being of the third world, if they really cared at all, frankly, they would be facilitating the building of desalination plants along the coast of every suffering nation to convert ocean water to consumable, usable water, and then they would filter organic nutrients from the ocean itself into hydroponic greenhouses. That would resolve the problem. The bottom line is that food, air, and water are only as scarce as we decide they are. If we choose to become intelligent and strategic with our production and preservation methods, while taking full advantage of technology, there is no reason why we can't provide for the Earth's people many, many times over. The starving children of the world today are not so because of a lack of available food and water. It is their lack of purchasing power, the failure of their economies, not true scarcity, which causes the needless deaths of millions a year. In the world today, one person dies of hunger every second because of poverty. Okay, back to our original exercise. These technological advances I have just spoken of, along with many others, would be coupled in with traditional methods and thus monitored and regulated in our systems approach as we have already expressed. The point is that new efficiency-increasing technologies would be quickly incorporated into the system based on qualifiers. Now, you will notice once again that choice becomes self-evident. As long as the integrity of our methods of evaluation, which is the scientific method, is strictly followed, coupled with the goal of maximum efficiency and sustainability, the process of societal construction and organization becomes almost entirely self-evident. We are arriving at decisions based on this simple goal of maximizing efficiency in whatever way we can. And this pattern of thought, this commitment to the objective observation of natural processes and loyalty to the scientific methodology utilizing hypotheses and testing, etc., leads us to part 3, with the introduction of an organization called the Venus Project. Everything that we have just talked about are the basic attributes of a social design called a resource-based economy. This term was coined by industrial designer and social engineer Jacques Fresco, who is the director of the Venus Project, which